Hi children, today I am going to explain the topic, the principle of inclusion and exclusion from the chapter permutations and combinations. It is one of the most important for JEE, either mains or advanced. See, for example, if you take the non-empty sets, this is A and this is B. Now, as everyone knows that this is called as A intersection B, which is common to both A and B. Now, the first point is n of A union B. We can write as n of A plus n of B minus n of A intersection B. N of A union B, n of cardinal number of elements of A union B, with the union combining both the non-empty sets. It gives that n of A plus n of B minus n of A intersection B. Why we are removing n of A intersection B part here? For example, this is set A. In set A also there is a part intersection. In set B also there is a common part intersection. Hence we are adding these two. We have to subtract, because since 2 times exists that part, we should subtract the 1 time. That gives that n of A union B. Why this principle is called as principle of inclusion exclusion? See, this is called as inclusion, that means adding, and minus of this, that means this is called as exclusion. Hence, based on the principle of inclusion exclusion, we write that n of A union B is equal to n of A plus n of B minus n of A intersection B. Sometimes in some textbooks we may see that like this. It is not modulus. Don't be confused that it is not modulus. The representation of n of A union B or n of A like that, we can also write in this manner. No, not only for 2, we can define these principle for n finite sets. If you go for that, for example, take 3 sets, n of A union B union C, n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. Again, this is the inclusion, and again exclusion, 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 and again inclusion. Again, based on the Venn diagram also we can show for taking 3 sets, say A, comma, B and C. Now, if we generalize this one, first I have given example for the 2 sets, non-empty sets, and example for 3 sets. Now, if I go for the n sets, this is actually very important for finding the formula for finding number of functions, number of onto functions, etc. In the next video, I am going to derive that formula for finding number of functions, number of into functions, number of onto functions based on the principle of inclusion and exclusion. Now, if you go for this, I can write this as, first of all, selecting one. First here, in this case, n of A, again n of A, since 3 are there, here 2 are there, here up to n are there. That means you write sigma, the summation, I running from 1 to n. That means selecting, this stands for what, do you know that? NC1. That means selecting 1 out of all A1 to AN. That means n of A1, and keep sigma, n of A1 plus n of A2 plus n of A3 plus so on up to n of AN minus, first see n of A plus n of B minus, here 2, here 3, here n. After what we got? Minus. Here also minus. Here also minus. Next 2. That means what? N of AI intersection AJ. That means selecting 2. IJ 1 2 1 3 1 4 up to 1n 2 3 2 4 up to 2n and so on. That means selecting 2 things out of n things. It can be done in NC2 ways. That means I can write this as sigma 1 less than or equal to I less than j less than or equal to n. 1 to n. 1, 2, 1, 3, 1, so on, 1, and similarly from 2 to n. Similarly from 3 to n. Finally, that n minus 1 to n. And again, plus. Now selecting 3. Sigma n of ai intersection aj intersection ak. It's nothing but what here? It is NC2 selecting. Here nothing but what, sir? NC3. Similarly, 1 less than or equal to I less than j less than k less than or equal to n. Applying minus so on, I can write up to minus 1 whole to the power of n minus 1. Finally, what here? N of A intersection B for 2 elements. For 3 elements, students, n of A intersection B intersection C. For n elements, we get that n of A1 intersection A2 so on An. This is the generalized formula for the principles of inclusion and exclusion. The first one is inclusion. The next one is exclusion. Again inclusion and again exclusion. The application of this inclusion exclusion plays a vital role in permutations and combinations and in other chapters also. Thank you.